Brilliant. Thank you very much for that. Great. Well, DetectOre, a new opportunity for fast and cost-effective exploration, or music to management's ears, should I say. Let me just get a clicker. So before I jump in to the story about DetectOre and how we've been utilizing it, I'd probably just like to give you guys a bit of an introduction about Ariana. So we are an AIM-listed company since 2005. We are an exploration, development, and production company. We have projects in prospective regions in Turkey. Our first operational mine was opened in 2017. It's called Kızıltepe, and we're producing about 20,000 ounces of gold there per annum. This aerial photo that you can see over here, I think that's it. That's the Kızıltepe plant, and over there you can see the Arzu South open pit and the processing facilities there. We have a second mine becoming operational later this year called the Tavşa mine. This is also in Turkey. But since 2020, Ariana has taken a refocus specifically back in exploration, pure exploration. But around about the same sort of time, the company diversified its expenditure into exploration into a strategic investment fund called Asgard Metals. And through Asgard, we invest in other exploration companies which we have built relationships with over the years. That way, we apply our team and our technical know-how into their projects to develop some new areas where we can contribute our knowledge to. And through Asgard, we now have interests in Australia, Laos, Kazakhstan, Kosovo, Cyprus, and our newest, biggest asset in Harare. In Bulawayo, in Zimbabwe. And so Ariana is somewhat of an unusual exploration company, or a junior exploration company anyways. Ariana has always been really focused on technology. And back in 2007, we purchased our own diamond drill rig, and we managed a drilling team for several years. And then back in 2012, we invested significantly in light spectroscope technology. We've operated our own ground mag surveys, and we've looked at various different applications of drone technology. By far, one of our most favorite pieces of technology is the portable XRF. It's an incredible instrument, and we've been implementing it and using it in all of our projects for the last 13 years. More recently, we've bought into the box scan technology. And this multi-parameter core scanning instrument is used for our internal research into big data, and also a little bit into AI applications for core logging. Ariana is a big believer that utilizing big data is the future for mineral exploration. We also believe that our effective application of technology over the years has given us a real edge in low discovery cost per ounces. So as you can see there, our discovery cost per ounce is about $11 per ounce of gold discovered, whereas the industry standard, or the industry average, is about $62 per ounce discovered. We are one of very few companies with a multidisciplinary specialist team, and we are, like I said, we're one of very few companies that have an investment fund. Asgard Metals, our fund over there. Bit of a funny clicker there, isn't it? So this is our specialist team, and really this is the team that drives our exploration to the cutting edge. And our team consists of exploration geologists, in-house geophysicists, remote specialist scientists. We also have financial modeling geologists, GIS analysts, field technicians, and everybody working together at the cutting edge of our exploration. So that is my 3-slide summary, or tip of the iceberg summary of Ariana Resources. And now I can jump in and talk about DocWare, Ariana's biggest, newest asset, where we've applied this awesome new technology called DetectOre. So back in 2022, DocWare was reviewed by our Asgard project generation team. It was concluded that this project was of significant interest to us, coming into Ariana's scope at the right time, with the right sort of scale, and also at the right stage of its development. So Ariana, through Asgard again, accelerated its investment and interest to an eventual merger with the prior owners, Rockover Holding, and this was completed in July 2024. DocWare is now Ariana's most significant 100% owned asset and contains two deposits, DocWare North and DocWare Central. We'll look at these again separate in a minute. DocWare North is the primary project carrying about 90% of the resources. So the project itself is located 110 kilometers west of Bulawayo being there, and the project sort of there. Collectively, we have measured, indicated, and inferred resources totaling about 1.8 million ounces across both DocWare North and DocWare Central. And the project is currently at a pre-feasibility stage. Also, interestingly, DocWare is located between two highly prospective greenstone belts. So to the northeast, we have the Bulawayo-Bubi greenstone belt, and to the southwest, the Mtengwe greenstone belt. So a quick summary of the geology at DocWare. DocWare is characterized as a low-grade orogenic gold deposit containing few quartz veins with several very high-grade zones, including zones where there's clearly some visible gold. The geology of DocWare North specifically consists of late Archean greenstone volcaniclastics, ranging from felsic tuffs through here. Also amygdaloidal dacites and tufaceous agglomerates. And the amygdaloidal dacites are actually quite a significant unit. For some reason, mineralization really is focusing in that specific lithological unit, which is currently part of some of the research we're conducting. These volcaniclastic units are then later intruded by a quartz porphyry sill, and then at some point, the whole lot is sheared and mineralized. Mineralization is seen within the pervasive shear foliation, but also within zones of lithological contacts. So specifically the porphyry tuff contact here, and also, as I mentioned, the dacite tuff contact there. Post-mineralization, the geology is locally overlain by Cambrian sediments, and then later intruded by dolerite dikes and sills. So there's one of these dikes through here and a sill up there. And then post the intrusion of these dolerite dikes into these Cambrian sediments, everything is then regionally overlain by Paleozoic, late Paleozoic and Cenozoic sediments. So in November 2023, Ariana initiated a due diligence review of the DocWare project. This consisted of drilling 4 diamond drill holes, totaling about 1,200 meters. This also included the completion of extensive database reviews, as well as completing our own in-house geochemical, petrological, remote sensing, and structural studies. A new geological model was built based on the work that we completed, and this was used as the basis for improving the resource model, or the resource estimation. The 2022 PFS economic study was also updated with more current economic inputs. And over here, you can see the DocWare North deposit, and all those white dots there are the historic collars. Down here is DocWare Central, and here in the middle is our base camp. This is where all the drill core is stored and the exploration team is housed. So you can just make out here DPD 130, 129. Those are our 2 DD holes or due diligence holes completed in DocWare North, and there are our 2 due diligence holes completed in DocWare Central. And while completing this due diligence work, we used these 4 holes here for our experimental analysis of the DetectOre technology, which we're going to jump into in a minute. But all this work that I've just listed there was completed in less than a year. So quite an awesome feat for a relatively junior exploration company, but that is the power of our in-house exploration team and technical team. So as I mentioned, we are real advocates for PXRF technology, and part of the pace of the work that we've been able to get through is being able to build really robust geological models using this technology. We initiated our due diligence review firstly with DocWare North. When we first came to the project, there was no multi-element geochemical data for any of the drill core. So it was quite difficult. Our general thinking of the deposit was quite difficult to model and understand the geology. There's obviously no outcrop at surface. There's about 40 meters of Kalahari and Karoo sediments covering all the basement geology. So there's nothing really to look at other than the drill core and get really into the details of the drill core. The general thinking was then that it was essential for us to get multi-element geochemistry on the drill core. And here you can see how we initiated that with the portable XRF. So this is our trained technicians spending 6 months sampling about 28,000 meters of drill core every day, which has built a pretty amazing geological model. It's provided significant understanding for us, not only for the geology, but also for the stratigraphic geometry of the deposit, which is quite an important implication, especially for something like an Archean geological setting. To date, we're now completing or initiating another 6,000 meters of analysis, and this is really just to help tweak the model some more. So yes, the geology can be modeled. Once we've finally sat down and looked at all the XRF data, as of January now, I've actually just flown off the plane. I got fresh off the plane 2 days ago. This is our latest geological model. And just to give you a bit of a flavor of how we've built this model using our XRF data, here's a little snapshot. So what we're looking at specifically here is a section through the Dockwin North deposit. We've got zirconium plotted on the drill strings. This is the XRF zirconium data. And clearly there are some hot zones in there that are in some holes and not in others. And these are mapping out volcanic tuff units. So felsic units tend to be quite high in zirconium levels. We can also look at something like cobalt. So there is clearly a cobalt depletion here in the upper surface of these drill holes. And we can use that then to map out the cover units. So that's that 40 meters of cover that I mentioned. And then using something clever like iogas, we can then actually build geochemical mapping of all the units through the deposit, including some of the faults. And you can clearly see where some of these major faults sit within the deposit. So the power of multi-element geochemistry is pretty significant in building these robust geological models, which are then very important for resource modeling. As great as PXRF technology is, like all technology, there are limitations, and I'm sure many of you already know some of the specific limitations relating to gold. In exploration samples, gold concentrations tend to be too low for the XRF really to detect. Gold also tends to suffer from spectral interferences in the form of matrix compositional errors and peak overlaps. So here's an example of matrix compositional error. So this is just where there is just too much noise for the XRF to really identify nice clean peaks, to identify really what it's seeing. And so it becomes difficult for it to specifically see through gold because there are several elements that overlap with gold peaks. And notably, some of those elements, I think I've listed in there, is tungsten, zinc, and bismuth. They are some of the ones that we've had some problems with over the years on gold deposits. So really the challenge here is how do we unlock the XRF by detecting or enabling it to detect low-level gold? And that is the perfect way that I can introduce DetectOre. It's a means to detect low-level gold in handheld XRF to levels as low as 20 ppb. Although through the work that we've been doing with our Olympus Vanta M series, we're pretty confident that actually the technology can go lower than 20 ppb. The DetectOre technology was invented by the Australian National Science Agency and has been exclusively licensed for commercialization to portable PPB. The DetectOre process overcomes the limitations that an XRF has by leaching the gold from the sample using a Lixivent, or in this case, it's a trademark chemical called Glix20. And then it concentrates that gold onto a collector device or a small tea bag-like thing called a CD. And then through that, then you're able to get a nice clean spectrum and a good solid reading. There is a little bit more to it, and we'll cover some of that. But in essence, the technology facilitates faster exploration. And interestingly, you can also get some insights into your ore characteristics. And these are sort of metallurgical characteristics, which we'll touch on to in a minute. It's a relatively mobile mini laboratory setup. It can be assembled in a day, in less than a day, and it can be deassembled in less than a day again. However, it is worth mentioning it obviously does require a portable XRF unit and ideally a workstation. So this is our setup. We're using a Vanta M series Olympus XRF and also the accompanying workstation that comes with that. And that's pretty much what the laboratory looks like. We've got a mixing unit there and various other mixing equipment and utensils there to mix up the solution that's needed, so the GLIX20 solution. So specifically going down the route for testing this technology on diamond drill core, which I believe we are one of the first companies to ever do this on diamond drill core. You do need to do a little bit of trial and error, specifically on barren core. Don't use your good core when you're testing this stuff initially. But the idea here is that it's important to try and modify your drill core, or your core, your saw, to enable the right amount of sample mass to be collected, and that's the swarf sample. So when you're cutting your core, the swarf is washed away by the blade, and what it is you want to try and collect is that swarf material. But you need ideally a specific mass of that material. So either you increase the size of your blade to collect more mass, or you need to come up with a different way, maybe cut it twice or something along those lines. To manage and monitor the samplings being processed by DetectOre, DetectOre has developed a proprietary software called PLIMS, and PLIMS works on a barcode system which systematically traces the sample through the process, which is incredibly useful. Before utilizing a portable XRF or DetectOre, you do need to install a specific analytical mode, which has to be done by the manufacturer, so ideally Olympus. Once all the necessary hardware is all set to go and the sample process is complete, there are generally 6 main steps into doing or analyzing your samples through DetectOre. And the whole process can take about 8 hours. So the process basically is you sort your samples after cutting them on the core saw, you collect your swarf, you sort your samples, you weigh your samples, so the critical mass, depending on how you're doing your analysis, is quite important. You dose your GLIX20 solution, and then you process the samples through the mixing barrel. You wash the CD collector devices, which are within the pouches in the processed samples, and you dry them, and then you analyze them with your XRF unit. It's a pretty simple process, but it's very effective. So this is a couple of photos of the guys on site. So here is our core saw. So we had to modify that with a special tray down here to catch the swarf samples. Some drill core you can't cut, things that are very friable and loose and oxidized and weathered. So we had to manually crush those. These are the samples drying, the swarf samples that have been collected. And this is the team setting up the laboratory, prepping all the samples. This is the mixer. And this are the collection CD devices that are being washed after the analysis. So this is what they look like when they come out, and they get dried in a little oven, and then you can zap them in your PXRF. Like any laboratory system, DetectOre's PLIMS does have a QA/QC protocol. Each batch of samples is about 90 samples. This is the maximum number of samples that we can actually fit into the barrels. With each of these batches, there are 2 reference materials provided by Portable PPB. Importantly, these are not certified reference materials, but rather they're more materials just to check that the leaching process has worked as intended. For DetectOre, for the DetectOre mode on your XRF, there are 5 calibration certified standards, which then, there are calibrated standards which you use to calibrate your XRF unit. And those calibration standards range from a range of gold or known gold from 0 to 1000 ppb. And then additionally to the Portable PPB QA/QC procedures, so additional to all of this, Ariana also inserts its own, 2 of its own field duplicates and 2 of its own blanks as well. So here is the results from our first round of analysis. And what you can see immediately is we've got fire assay on one side, all the samples that we tend to send for analysis, all the samples from the first hole that we analyzed. We sent a whole batch for fire assay, and we also sent the whole batch for DetectOre analysis. And what you can see here quite nicely is wherever we've got a fire assay hit, we clearly have a DetectOre hit too, and they correlate very well, even with some of the lower grade gold analysis there. So when we were cutting the swarf samples, we can collect about 20 to 30 samples per day. This is a little bit slower than normal cutting of core, and the reason being is because we do have to wash down the core saw after every sample. The specific units that you report gold as in the DetectOre system is called DetectOre units, or DU. And these DU don't quite correlate directly to parts per billion, but there is a formula where you can then apply that formula to get parts per billion equivalent results. My colleague Ruth Woodcock is here in the crowd, and she'll happily tell you how this is all done. So those questions can be directed to her. For the last two holes at our DocWare, so the first hole, basically, we sent all the analysis. The second hole that we tested, we basically used the DetectOre to determine which samples should be sent to the laboratory. And this is where the cost saving comes in. So you allow DetectOre to identify samples that contain gold, and then those samples are sent to the laboratory for assay rather than sending your whole stream of samples. So for the second round of samples that we did for the DocWare Central project, the very first hole we sent off again. We always tend to send the first hole off and get all of that analyzed so that we can look at the correlations of the results. And then from there, we can then tune into the DetectOre data and allow us to distinguish which samples should be sent to the laboratory. So in the last batch, eventually, out of 270 samples, only 21 samples based on DetectOre's evaluation of the data was sent to the laboratory. So this is a little bit what the results look like. By the end of the DetectOre trial, we processed over 1,100 samples, including 116 QA/QC samples. The overall correlations between DetectOre and assay laboratory results range from 0.52 to 0.99 R², depending on what material was being processed, and that's quite important. We'll touch on that in a minute. The average R² value of our analysis was 0.81, so that's pretty damn good, sort of 81% correlation. And in fact, the correlation between the DetectOre results and our assay results appear to even be stronger than lab-to-lab correlations. To further understand the range of correlations from our results, we have to dive deeper into the data by reviewing some of the geological context. So you can't just look at the data, you have to consider the geological aspects too. So from this, we were able to understand that obviously weathering plays an important component, but also lithologies. So we had strongest correlations from our quartz porphyry and dacite units, and we had weaker correlations in results from felsic tuffs and rhyolites. And then for the DocWare Central project, we actually had quite poor correlations in schists specifically. And again, we're not sort of understanding exactly why, but some of the research that we're doing will eventually answer some of these questions. As I mentioned to you, you can use DetectOre. If there's enough data, you can use the DetectOre system to get an understanding of the metallurgy of your deposit. So as I said, oxide and to some degree transitional material has stronger correlation. So the gold is leached from this material, as you expect, much easier as opposed to sulfide samples. However, if you get enough data, you can actually use this information to build a bit of a rudimentary metallurgical domain and get a bit of a how your deposit will respond in terms of its metallurgy. So again, it's just another application of DetectOre. And something that we're interested in trying is how we can apply DetectOre in grade control sampling. Being such a fast system, grade control is always an area where there's time constraints and pressure. So it'll be quite a useful way to get results pretty quickly. So in passing conversation with the DetectOre team, it sounds like there are quite a few exciting updates to the technology on the horizon, including simplification of the process. So one of the ideas is that they will have a pre-prepared pouch, and there will be your Glix 20 solution in the pouch, and all you actually do is add your sample, add some water, and away you go. So there'll be no need to do sort of batch mixing of your solution. There'll be no need to do dosing of the solution to pouches. It's just a quick solution how to get results a little bit faster and also introduce less human error. There's also news that PLIMS, so the system that operates the DetectOre technology, will open up in the next few months for silver. And this is quite exciting for us specifically as well, because that will lead to more cost savings in our future work. And some of the trial work that we've done in silver, which was supervised by the DetectOre team, showed that we can get really good correlations in the data, both for gold and silver, when the silver values are around about 80 DetectOre units. And what that really translates to is quite low levels of silver. So in my closing remarks here, quick, Ariana has performed exceptionally well as an explorer, developer, and producer, partly due to being an adopter of key technologies or cutting-edge technologies. Ariana does believe generally in big data science and is a means to sort of solving exploration challenges. We are backed by our in-house specialists in geosciences, and we also have the power of our Asgard investment fund, which we'll utilize to the benefit of our partners whilst building data and experience. In our latest interest in portable detector technology, there has been some outline there of how we can apply this for future cost savings and specifically time savings when out in the field. And as a result, we're looking forward to expanding our experimentation with this new technology, and specifically in 2 new laboratories which we've set up, one in Africa and one in Europe. So that's it in a nutshell. I do have to pay credit to Ruth Woodcock. She is one of my colleagues here in the crowd today. And had she not been very shy, she'd actually been the one up here and you wouldn't have had to listen to me rant on. But do speak to Ruth if you have any specific questions about the processing. She's a bit of the architect about setting up our system and also keeping everything in tip-top shape, specifically with the QA/QC. Brilliant. Thank you.